talking about more rules of logarithms. Now, up to this point, our discussions about logarithms have consisted of taking the logarithmic form and turning it into exponential form, or the exponential form and turning it into logarithm form. Today we're going to take that and we're going to develop it. We're going to look at more complex situations with rules and properties of logarithms. So the very first thing that we come up with is the inverse property of exponents and logarithms. Okay, so this is somewhat complicated. All this stuff is in your book. I just took the time to try to put it in a slide format for you. So the first thing that they show you is that if we have b, which has a log as an exponent, and that log exponent has a base that's the same as my number that's sitting out front, then essentially what's going to happen is that this is going to cancel out, leaving me with x, because what will happen with this is that that exponent can actually be, well, in a sense, moved. So log b to the log b x is just going to equal x. So whatever goes here, given in this situation, is going to be my solution. Okay, so that should kind of cut through some of the work that we have to do. This one over here shows me that if I have log with a base that it's the same as its whole number and it has an exponent, that the answer is going to be that furthest up exponent. All right, so you see examples of each of these worked out down here. For instance, if I have 2 to the log 2p, then basically what ends up happening is that those 2's and those logs cancel out and my answer is in just p. All right, over here with this rule, if I have log base 5 to the 2c plus 3, it actually equals just 2c plus 3. And this one I can explain maybe even just a little bit better, because log base 5 equals 1. Okay, and the reason it equals 1 is because if I wanted to just find this, I can write this in my calculator as log 5 over log 5. Well, what is anything divided by itself? 1. Okay, so if I have a number down here and a number up here and they're the same number, essentially what's happening is I'm dividing it by itself. So that becomes just 1. So the other thing that happens with this is that this 2c plus 3, when it's up here, can be moved out front. So this 2c plus 3 gets multiplied by 1, so my answer is just 2c plus 3. Okay? I don't know how much that makes sense. I'm hoping that as we get into examples, the things that don't make sense right now as I'm introducing them to you will make sense later on. Okay? All right. So that's the inverse property of exponents and logarithms. Essentially what we're saying is that these exponents here become our solutions. All right, the next thing is what is called a change of base formula. And this is for instances where when we're looking at this, okay, where I have log base b equals x, that equals log base, let's see, and I don't know if I've left something out of this or not. Let me look at my page. So I feel like I've left something out of that picture. Okay, where I have log base bx, that equals log base a x over log base a b. Okay. Essentially this is just kind of what I was talking about earlier. Remember how we had log base 5, right? And if I wanted to solve that, I would put log 5 over log 5. Okay, well this log base bx is log x over log b. Okay, all they're saying is that we're using a now as our base. Okay. Now the standard base of any log, if it's unknown, is 10. 10 is the standard base. Okay, so that's why log base bx equals log base x over log base b. Okay, are we following so far? Okay, and that's what's called change of base. All right, can we move on from there? Okay, if you have questions, stop me. Okay, this is the product property of logarithms. So what does the term product mean? Multiply. Okay, so for any positive m in b where b does not equal 1. So what we're saying here is the logarithm of a product is equal to the sum of the logarithms of its factors. So if I have something like log base 2 32, that's the same as log base 2 4 times 8, or I'm trying to think of other things, 2 times 16. That's the same thing, okay? Otherwise, we could split that apart and make it log base 2 4, which is what we see there, plus log base 2 8. So what it becomes as I split them is that it shows up as addition. So whenever they have the same base like this, okay, because they have the same base, I can technically drop off that whole log base 2, okay, and I would get 4 times 8, and so my answer would end up being 32 in that instance, okay? So log base 2 32 is equal to log base 2 in anything times something that's going to equal 32. And if I wanted to split that up, I would get those two separate logs to that same base added together. So whenever it comes to multiplication is attached to addition in logarithms, okay? And what we're going to see here in a second is that division is attached to subtraction, okay? Over here, we get another example. If I have log base b m times n, that is the same as log base b m plus log base n, okay? Multiplication becomes addition whenever I split them up, okay? If I had this, I could put them together through multiplication. Okay, wobble your head up and down if you at least understand the words. You don't have to understand why, you just need to know that that's what happens. Okay? All right. Then we have the quotient property, which is what I was just addressing, right? If we add and multiply as we change forms, then we're going to change forms whenever we divide. Okay, the logarithm of a quotient is equal to the logarithm of the divided minus the logarithm of the divisor. So if I have log base 5 16 over 2, then I have log base 5 16 minus log base 2. Or if I have log base b m divided by n, the opposite happens. I can write that as log base m minus log base n. I'm going to take the divided minus the divisor, not the other way around. Again, all of this information is in your books. I'm just hoping that as I put it up here, I can kind of point out some things a little bit more clearly. Okay, finally we have the power property of logarithms. So we're taking logarithms to a power. So for any real number p and positive numbers a and b, where b does not equal 1, so the logarithm of a power is the product of the exponent and the logarithm of the base. So if I have log 10 cubed, that equals 10 times 10 times 10, or log 10 plus log 10 plus log 10. Because remember, multiplication becomes addition as I split them up, okay? And it's going to become as many 10s as I have. Or essentially, remember that I said that we can take this guy right out here and move him forward, which is how we get 3 log 10 as a different form. Okay, if I have log base b a to the p, then I can move the p out front and get p log base b a. Okay, so that exponent can move out front and become the coefficient of the log. How many of you are totally and utterly lost? It was information overload. Okay, so I've got a couple of people that are willing to admit it. Everybody else is lying. Okay, because it is information overload. It's a lot. Okay. I address these things kind of one at a time, but it's going to take some practice before you're kind of getting the hang of it. Okay? Don't get intimidated. We'll just practice. Okay, so let's look at this first one. And then, of course, the first question they throw in here gives me a natural log question where it's, and we don't have anything in our book so far in this lesson at all that you're going to see is going to delve, well, you'll see something. You'll see this kind of matches up a little bit with what you'll see in, like, let's say example number 5. Okay? But I don't believe you see anything like this in your homework. I'll tell you what the answer is. The answer is e to the 1/6. Because what you have to remember is that that e has an exponent of 1. So just like a variable, if I wanted to pull it out of the square root, right, it's going to have, right, 1 divided by 6. So my answer is actually e to the 1/6. So if we simplify this, we should just get d, because we're just looking for the exponent, which is 1/6. Okay? All right. Again, not a question I want to focus on, but it is there. Okay? All right, let's come down to question number 2. Write log base 520 as a base 10 expression. Okay, so this is how we do this. Essentially what we're saying is that we want the bases to be 10. In order to do that, what we're going to do is we're going to do that division that I showed you. So in order to find the solution to this, we're going to write log 20 divided by log 5. Because what is the log when it's not shown? What is the base whenever it's not shown? 10. So now what you see is that this is 10 and this is 10 whenever I divide this by that. Okay? So that's how I write this as an expression with a base of 10. So I get C as an answer. Does that make any sense, or at least we remember the correlation that goes with that? Yes? Okay. I get a couple of heads wobbling around. Okay? I did that, but that's okay. All right, number 3. Number 3. We have about 10 questions. Okay, 3. Evaluate log base 36 to 16 if necessary. Round your answer to the nearest 10th. Okay. Some newer calculators, you can do this, right? My calculator will do this, but if you have like a TI, an older TI 84 plus, right, it's probably not going to do this. Okay, so I'm going to just show you the standard way. We're going to solve number 3 the same way we would have solved number 2 if we'd actually plugged it in our calculators and gotten the answer. So what we're going to do is we're going to rewrite this. How am I going to rewrite this so that it looks like number 2? Log what? Log base 10 to 16, but I don't have to write the base. Okay, it's automatically 10 whenever I don't have it. So log 216 over what? Log 36. All right, so we want to solve that. All I have to do at this point, because any old graphing calculator can do this, okay, is type in log 216, close up my parentheses, divide by log 36, close up that parentheses, and get the decimal answer of 1.5. Now, you might have a newer calculator that will do this for you. And if you want to know, where do I find this? Okay, you're going to hit math. You're going to hit the math key. And you're going to go down until you find something that's that's going to say log base. Now, not everybody's calculator will have this. Okay? How many of you have a log base when you scroll down in math? 1, 2, 3, 4, 5, 5, just 5 of us. All right, so if I hit enter on that, okay, hit math, go down to log base, what I can do there is I can type in exactly the way that it looks right here. Okay, I can put 36 in my base, and I can put 216 right there. Scroll over it, and I'm still going to get the same 1.5, correct? Okay, but everybody in here can do this and solve this, correct? Okay, so if it says evaluate, and it gives it a base, and it gives it, all right, I'm going to take that I'm going to divide by my base, okay? But it's got to be log over log. How many of you understand what we just did there? Handful of us, hopefully. Okay. Let's look at another one. This one is another evaluate log base 4 1/16. If necessary, round your answer to the nearest 10th. Okay, Exactly the same thing. It says evaluate, gives me a log with a base, gives me 1 over 16, right? You guys should be able to do this. If you're listening on the video, I'm going to have you guys as students actually do this and show me your answer. Everybody in here should be able to do this, except for the people that still refuse to pick up a calculator whenever they enter the room, right? Right? You can't do this without a graphing calculator, or at least a scientific calculator. Okay? You got an answer? You don't have a calculator. Okay. All right, Christian, why don't you tell me what you got when you get it? -2. Anybody else get -2? Hopefully all of us got -2. All right, so we can do that in our calculator. Now, there is another way to do this. I don't want to confuse anybody, but if you remember how we've converted from logarithm form to exponential form, do you guys remember how to do that? Yes? Okay, so if I wanted to convert this to exponential form, what would I do? Bring the 4 up, switch the x into 1/16, right? So there's 1/16. What happens to the x? Does it just go right here? It's an exponent because it's exponential form. So we're saying 4 to something equals 1 over 16. This is what I want you to see, that this would be 1 over 4 squared, correct? All right, could I move that 4 squared up? What happens to the 2 whenever I move it up? Becomes a negative. So 4 to the x is equal to 4 to the -2nd, right? So what does x equal? -2. All right, I'm not saying that you have to solve that way, but could we even solve this question without a calculator at all? Absolutely. All right. My aim here is not to confuse you with showing you 3 different ways to solve it. My aim is to give you multiple options. Okay. All right, number 5. Which of the following is the first incorrect step in simplifying log base 2 16 times 64? Okay, so they show me the first step. They pretty much just write it out. Log base 2 16 times 64. Look at step 2. Can anybody tell me what they did wrong in step 2? It should be what? They should have changed it to addition when they split it. Okay, do you guys see that? So step 2 is where they made the mistake. Okay, it should have been 16 plus 64. Okay, and then they're going to do everything else wrong from there on out. Okay, they're going to end up with 4 times 6 and all this other stuff that should not have come out that way. Okay. All right. All right. So step 2 is where they made the mistake. It should have been addition. All right, let's go on to question number 6. Now, question number 6 is, again, it's going to allow us to do this in our calculators to a degree here. Actually, we're going to find that if you plug these different things in your calculator, you're not going to get any of them correct. Again, I'm not a huge fan of this question, but we could move that x out front, so we'd get x ln 3, but we're not going to find... obviously that's not the same as ln 3 over x, right? Because it's not division. We've got a product here. It's not 3 ln x, right? It's not 1/3 ln x, and it's not ln x plus 3. It should be x ln 3, right? We're going to move that exponent out front. Does that make sense? So because we don't see that in here anywhere, our answer is A, none of these are correct. Okay, none of those follow the rules. Okay. All right, number 7. Oh no, it almost looks like I skipped number 7. Let's skip number 7 for now. We'll come back to it if we have time, or it may just help you try to get into your book. Okay. Number 8, you guys should be able to do that on your own. You have at least 3 different methods. Some of you can use your log base function in your calculator. Those of you that can't do that would do log what over log what? Log 64 divided by log 8. Or if we didn't have a calculator, what could we do? Could I convert this to exponential form? Yes or no? Yes? All right, so that would be 8 to the x equals 64. Can anybody tell me what x would equal then? 2. Did you guys get 2 when you plugged it in your calculator? All right? You see, like, if you know what you're doing and you know how to change forms, you can do some of these just as fast pencil paper as you can with a graphing calculator. Okay? All right. And I don't want anybody rushing off because I do want to be able to get number 8 done at the very least. Okay? It says rewrite natural log. We got our question here. All right. So the first thing I can do is do what with the 8? What can I do with the 8? Move it to the front. Move it so that it becomes the coefficient. All right. So I can rewrite that as 8 ln 3e over x. Okay? Now, this is division, correct? So I can rewrite that as what? What can division be rewritten as? Subtraction. Okay? Now, because this is 8 times all of that, what I can do is I can rewrite this as 8 times all of this, 8 ln 3e minus ln x. Do you follow me so far? Okay, so we saw how to do that. Okay. Now, this is multiplication. What can multiplication be rewritten as? Addition. So I can spread that out, and I can make that 8 ln 3 plus ln e minus ln x. Do you follow me so far? Okay, good. All right. Let's see. Now what we're going to do is we're going to redistribute that 8 back into everything. So I'm going to write this as 8 ln 3 plus 8 ln e minus 8 ln x. Still with me? All right. Now ln e is equal to 1. So that's 8 times 1. So finally I'm going to write 8 ln 3 plus 8 minus 8 ln x, and that's it. There's nothing else to change there. Okay, do we understand the steps involved in that? Okay? Now, we don't really quite have enough time. Well, we might have enough time. If you remember this from your very first earliest notes, do you guys know what your answer here is on 10? What is it? C plus 3. Right? Because we've paid attention at the very beginning of the lesson, we don't have to do all of the malarkey that's going to come with that. We're going to get C plus 3 times 1, which is C plus 3. All right. That finishes it off. The only thing we didn't do is 7. I won't have you really worry about that. Okay?